Welcome to A Software Engineer Plays, the YouTube channel where a software engineer, that's me, plays through games that are designed to teach you how to write some code. This looking at human resource machines is going to be a multi-part series. Let's dive right in. Alright, let's go ahead and get started. Level 1 of human resource machine, the mail room. Year 1. Alright, it's our first day. We got 3 numbers coming in. We got 4, 6, and 1. That looks like an excellent instruction follower. Okay. This is our job. Okay. Alrighty. So, looks like we're going to be building a program over here on the right side. Tell our worker to do things. Okay, so let's go to the inbox and then straight to the outbox. And let's do it 3 times. It looks like we've got 3 numbers, so let's move 3 boxes across. Let's see. Alright. So far, so good. Moving on up. Good stuff. Okay. Level 2, a busy mail room. Alright. It took us a year to do that last one, and we're in year 2 now. We got some boot sec. We got promoted, everyone. Alright, a new assignment. So we got a jump command now, so we can jump around inside the program. There is there's a statement you can use in some programming languages called a go-to statement, which is similar. It's basically it'd be like kind of like a loop in a way, but a little bit less elegant. So basically what this is going to let me do is tell it where to jump to in the program. So it says once I get to line 3 here, we're going to jump back to the start of the program and go through it again. So see, kind of like a loop in a way, but it's not a formal loop structure. It's just jumping the place in the code. So go ahead and run this. You can see we go to inbox, outbox, and then we jump back to step 1. So we'll just go ahead and speed up our little man here. It seems to be working. Alright. You get jump sequences in sort of more low-level programming languages, a lot of assembly languages that operate on the actual processing unit of your computer might be executing jump statements, but most higher level languages would rather use loop structures like a for loop or a while loop to do that kind of operation. Alright, floor 3, the copy floor. Year 3, let's see what we gotta do here. Oh no, the inbox conveyor's completely broken, but that doesn't mean we get to take a break from work. Alright. Ignore the inbox and just send the following 3 letters to outbox, B-U-G. Okay, so some items, the carpet. So we gotta figure out exactly, okay, so we want to send B-U-G, so it looks like we're going to copy from, looks like B's in slot 4, so let's see if we can, okay, select it there, so we want to copy B, and then U, well, we're going to go to the outbox first. Now, I would want to use a jump statement here, but if I do that, you can see it's going to try and copy from 4 every time, and there's not going to be anything in 4. So we don't want to do that. Instead, I think we want to just go like this. I don't think there's any way for us to change that parameter on the copy from command every time through, so let's go ahead and get the G and move that to the outbox. Let's see how this works. Okay, so we copy from B and move it over there, then we go to the 0, go over there, and then the G, and go over there. B-U-G. Alright. Good stuff. So it looks like this game's kind of trying to emulate a more of a low-level assembly type language with the commands that it's having us execute. Copy from, copy to would be kind of like what we call a register in assembly. Basically, it's a bank that stores a number, so you can copy to this bank a certain number and then copy from it and do things like that. And that's more low-level computing that like a computer engineer might deal with. But software engineering usually deals at a higher level, writing code that's more easily readable by humans. Alright, let's jump into level 4 here, the Scrambler handler. Okay, so this is year 4. Okay, the conveyor system's been fixed. It only took a year. What do we gotta do? Oh, we gotta get to work. The data won't collate itself. Okay. So we gotta swap, basically. So we want to take the 3 and the 9, and then send the 9 out first, and then the 3. So we want to copy these into our carpet area here, which you could call, it's kind of like memory in your computer, I guess, but basically we want to pick up from the inbox, I think, pick up that 3 and copy it to, we'll copy it to slot 0. Then we want to go back to the inbox and copy that to slot 1. Okay. And now, we want to send out the first item. Or actually, let's think about this. We don't actually need to store the second item, right? If you think about it, because storing it's just an extra step. We could send that one straight there, then pick up the one that we stored. So let's get rid of this copy too, and let's just move it straight to the outbox. Then we should be able to copy from the space that we stored and move him straight to the outbox. Now that should work for the first 2, and then because this code is reusable, we should just be able to make it jump back to the start and just execute all of these steps over and over again. It'll pick up 2 and reverse them. So let's see what happens here. So he's going to store number 3. He's going to pick up the 9 and move it straight across. And he's going to pick up the 3 and place it. And then he's going to continue. Looks like the end's going to overwrite the 3 there and move it across. Pick that up. And we're going to do the same thing. We're going to store the 1 in memory here. Pick up the 9, move it across, and then pick up the 1. So basically this is teaching you how to swap 2 numbers, and it's a pretty common thing that you need to do in programming, especially when it comes to sorting lists of things. You've got one item that's larger than another, and you want to say sort things from smallest to largest. If your first number is larger and the second number is smaller, you want to swap them. But what this is teaching you is that more often than not, you need to have a place to store one of those numbers while you're doing your swap. So the traditional method for swapping in programming is to create a third variable that we would call a temporary variable, and we would set that variable equal to the value of the first number, and then we would set that variable equal to the second, and then we would use our temporary variable to write back to the second number. And maybe I'll do some basic drawing and have that overlaid on the screen here to help explain that. Alright, so just a little further explanation on that swapping there. So basically, I figured the best way to do this would be to show you how code itself would actually look. So we'll start with a little function declaration. You don't really need to worry about what that means, but we're going to declare a couple of what we call variables. These are integer types. So we've got a equal to 5. 5's the blue circle here. And we've got b equal to 10. b is the yellow circle down here. So to do a swap, we might be tempted just to set a equal to b. So we did that here, right? b was equal to 10, so now a equals 10. But now, a is equal to 10 and b is equal to 10. So we've actually lost the original value of a. We have no way to know that a was 5 anymore. So it's not going to work. So instead, what I mentioned earlier was we need to have a third variable. So we'll start out like we did before. We'll declare a and b, blue and yellow, 5 and 10. And now we'll do the swap. We'll declare this third variable called temp. It's an integer type. Temp, we'll set it equal to a. So temp here is equal to a, which is equal to 5. So it's just a copy, basically. And now what we'll do is we'll do what we did before. We will set a equal to b. So now we see we've got two values of 10, a and b are both 10, but we also have this temporary variable which is still pointing to the value of a from before, which is 5. So now what we can do is a third operation and set b equal to temp. And now you can see that what once was 5, a was once 5 when we started the program up here, it's now 10. And b, which when we started was 10, is now 5. So we had to do two swaps, actually, to swap one set of numbers. So hopefully that clears it up a little bit with the pictures and get to see a little bit of actual code there. Let's move on to the next level, level 5. Coffee time. I'm a big fan of coffee, so I resonate with this. Cool. Had some good coffee this morning. Let's look at these.
Back to work, everyone.
This lady's getting some coffee. We gotta get back to work. Okay. Oh, newsflash.
Regions of the city continue to experience power failure.
Oh no.
Local authorities are investigating.
Alright. Looks like the power has gone out. What are we gonna do? Oh, okay, well that was pretty easy level for us there. Move on to level 6 here. It's a rainy summer in year 6. Okay. Looks like the carpet's turned green. I don't know what that means. But it's raining outside. It's dark and stormy. Alright. Okay, so we're doing some math now. So now what we want to do is add two numbers together. So let's see, how does the add command work? Okay, so it adds the contents of a tile on the floor to whatever your value you're currently holding. Okay, so that's good to know. So basically what we're going to want to do is similar to the last one where we copied, we need to store the first number in memory. And then when we're holding the second number, we need to add that number to it. So we will pick a number from the inbox and we will store that in memory. We'll just choose index 0 there. It's another thing, a lot of computer systems are what we call zero indexed, which means that the first slot in memory or in whatever structure you're looking at, like this carpet, the first slot we would call index 0. It's the first position, but we would refer to it by 0, and then the last position is 2. So this carpet has 3 slots in it, but the highest slot is number 2 and the lowest slot is number 0. So Just a way that the computers tend to handle numbers. Anyways, we'll pick up number 1 here, and we'll store it in slot 0, the first slot. And then what we'll want to do is we'll pick up the next number, which in this case would be 9. And then we just want to add it to what's in 0. And then we should be able to just move that straight to the outbox. And that ought to do it. The one question I might have is what happens to the second number, but I don't think it's going to be a problem here. And then because this code is, again, generalizable, it's generalized, so it doesn't care what's in slot 0. As long as there's a number in there, it'll add it. We should just be able to loop or do a jump to go back to the start and then keep adding 2 numbers together. So let's see how this works. So pick up 1 and store it in slot 0. And we pick up 9, come along, add them together, and 10 goes on there. Okay, so we'll do 6, we'll pick up the 7, add them together, get 13, good. Okay, we got a negative number now, that's interesting. Let's see what happens. We're going to add 2 to -8, we should get -6, okay, looks good. And now 1 plus -1, we should get 0, let's see. Alright, good deal. Alright. Another level complete. Let's see what's up next. Alright, so looks like we've got a couple of paths to go down here. I think I'm going to finish off this yellow line and then we'll call it a day for this video. So let's take a look at the tripler room here in step 8. Who are you? This optional area is for high-performing employees only. Oh, well, thank you very much. Is that you? Well, you're late. Oh, we are 7 years late. Oh, no. I want to see 100% performance increase. Your performance will be evaluated with extra scrutiny. Alright. So we need to triple the number. So one thing I noticed in the earlier levels was that the number in memory stayed there even when we copied from it. So I think what we should be able to do is go to the inbox, copy to slot 0, and then we should just be able to move to the outbox 3 times. But I know that they are now evaluating our performance, so I can actually well, let's see, no, I can't speed things up because the jump isn't terribly smart. I can't just say jump 3 times, so if I do that, it's just gonna go to the outbox. Just forever. So that's no good. We can't do that. But, let's think, what else can we do here? Oh, so I'm misreading it. See, I thought we needed to copy a number 3 times, but actually we need to multiply a number by 3, so we need to add it to itself 2 additional times. So the copy 2 is still correct, but then what we need to do is pick it up again, so we need to copy from 0. Does that make sense? We're going to copy it there, then we're going to pick up a copy of it, and then we want to add once. So that would be, let's see, 3, pick up a 3, add it, that would be 6, and we want to add again. So that would be multiplied by 2, that would be multiplied by 3, and then we move to the outbox. Let's just look at this now and think, is there any way we can speed this up? I don't think so. So we'll go ahead and put in the final jump statement here so that we do it over and over and over again. And we will see what happens here. One thing I do have a question about is this negative number. If you triple, because we're adding here, it should be okay. If we were going to do a straight multiplication by itself, then we might run into trouble because the sign flips every time, right? If you multiply a negative number by a negative number, you get a positive number. But if you multiply that positive number by a negative number, you end up with a negative again. Because we're adding here, that shouldn't be a problem. So let's see what happens. I'm going to store that 3 there. And we're going to add it, pick another, add it. So we triple 3, 3 times 3 is 9. Alright, now we're going to do the same with negative 3. Put it there, add it, get -6, add it, get -9. Yeah. -3 times 3 is -9. Do the same with 2. Okay, 2, get 4, add another 2, we should get 6. Looks good. Now we come in and do 0. Okay, 0 plus 0 is going to be 0, and 0 again, 0. Alright. How did we do? Okay, size. Oh, okay. So we can do it in one fewer. Okay, let's see if we can figure this out here. So trying to think. 1, 2, 3, 4, 6, 7. Yeah. So one of these isn't necessary. Or we can slim it down. How are we gonna do that? We have to store it in order to get a copy of it. Maybe we don't need the copy from. Let's see what happens here. Because if we just put it in 0, we're still okay. Yeah, that's it. So we're still holding on to it, so we don't throw it away, and then that makes sense. So the copy from, we didn't need an additional copy, so that's how we optimized that. There we now got our 6 steps, and we should get our 24 operations. You see, in earlier missions, I'd seen our little guy throw away the number after he did the copy to, so I thought we needed to copy from after copy to, but it makes sense that that's kind of an unnecessary step. Alright, we did it! Okay, let's move on to the Octoplier. Sweet. Let's see what we get here. So I think we're going to be multiplying a number by 8 essentially here. Is there anything in life more thrilling than self-improvement? I don't think so. Can you do it using only 3 add commands? That is an excellent question. So let's think about this. Clearly we're going to need to pick up something from the inbox, and we're going to need to store it. And then what? Using a bunch of add commands. Okay, so oh, I see. Okay, so here's what I'm thinking. If we copy it to 0, right? We're gonna store 5 there, and then we want to add. So we're gonna get 10. Then we want to copy it to, and then we want to add again. So we're gonna get, let's walk through this. We're gonna have 5, add to it, we'll get 10. We'll add to, well, we're holding 10, we'll add 10 again, we'll get 20. And then if we do it one more time, we should get our 8. So essentially what this is doing is a squaring process. So in computers we deal a lot with powers of 2. And if you think about it, if you have 2 numbers, let's use 2 just as an easy example. You have 2 and 2, and you add those together, you get 4. Then if you take that, 4 is 2 squared, 2 times 2 is 4. If you take that 4 and add another 4 to it, you'll get 8. So 2 times 2 is 4, times 2 again is 8. So that's 2 to the 3rd power. 2 times 2 times 2 is 8. So you can see by doing these 3 copy options, that's essentially doing the operation of the exponent. So this should do it here. I'll step through the logic before we run the little man again. We're going to copy 5, so we'll have 5 here. We're holding a 5, so we'll add to it. We'll have 10. Put 10 here. We're holding a 10 already, so then we will add another 10 to it, we'll get 20. Store 20, we'll add that 20 back to our hands and get 40. 5 times 8 is 40, so then we can move it to the outbox and that should be good. So we'll go ahead and put our loop in here and see how it works. So 5 comes in, adds the 10, stores it, makes 20, makes 40, and out we go. Okay. So -4, we get -8, we get -16, we should get -32, and out we go. So for 1, we should end up with 8 here. 2, 4, and 8. Beautiful. And then 0 again, we should just get 0. So let's see what happens. 0. 0, and last time 0. Okay. Looks pretty good to me. Let's see how we did in our performance. 9 or fewer. Nice. And 36 steps. Excellent. Alright, off to the elevator. Okay, so Tetracontiplier. Tetracontiplier. What? How many is that going to be? Tetras 4. When all your work over the last few years comes together, it culminates in a well-executed assignment. Multiply it by 40. Oof. Okay. So in this case, we're not going to be able to use powers of 2 because 40 isn't a power of 2. The nearest power of 2 is 32. And that's 2 to the 5th. So I think we're going to have to do the add that we did last time 5 times. That gets us to the 8th. Go again. Okay, so that's times 8 there. That should be times 16. We'll do it again. That's multiplied by 32. But now we need an additional 8. So what I'm gonna do is use an additional I'm actually going to copy to... I'm going to use 2 memory slots, I think, here. Because I want to get the number times 8 separately, because 32 plus 8 is 40. So then I'm going to do this copy to operation 3 times in slot 1. One more. Okay, but we got a problem. We've got to copy 2, 0, and 1 first, so we have the same copy of the number. Then we want to pick up the number in 0 and start there. Okay, so by the end of this, we should have 32 times the number in our hands. We always want to add it to what's in 1. And then move it to the outbox. Let's just see if this works one time. Pick up the 1, we've stored them both. Okay, we're gonna get 8 times here. Uh-oh. Okay, alright. You see that we missed a store operation, so we want to copy, we want to do the last copy too here. Okay, let's see how this works now. So 4 times 8 should be 32, so we should store 32. Then we're going to go over here and get 32 times 4, which is a big number, 128. And then we add those together, 160 should be 4 times 4. So I think we're good to go. They're unhappy with me because I didn't put my final loop in here, but I will go ahead and do this here. We'll step through it and see what happens. I'm not sure if this is the most optimal solution. Let's see what happens here. big number there, 240. I'm gonna speed them up. Alright, how do we do performance-wise? It's a lot of steps. Let's see. Okay, I used a lot more. So let's think about it now. So we get our 32, and we get our 8. What can we do to speed that up? Oh, okay, so you know I'm using the 2 registers, and that's fine, but here's what I'm noticing. Okay, we don't actually need to do the operations multiple times. So, because we already get the 8 here, you can see after this step here, we should be at the number times 8. So I'm actually going to put another copy 2 here. And then what's going to happen is we're going to get 8 times the number stored in register 1 here, bank number 1, and we're also going to get it stored in 0. Then we're going to keep doing the multiplication to 0 and then add it to 1 after the fact. So let's step through and see if this works. We get 6, there's 3 times, so there's 8 times, and then we keep on going. But I'm noticing we're still 1 over, so I think... Let me see if I can pause it here, where I think we can optimize. Yeah, so it's right there. We can actually add from 1 here instead of copying to 0. Does that make sense? So if instead of copying to 0, we just add what's in 1, then we've saved ourselves a step, because we had the result of 8 times the number stored in 1. We don't need to store it in 0 and then keep moving here. So let's go through. We'll store 3, we'll add it again, get 12, get 24, store it there. Now we'll come back, we'll add that, and then store it over there, and then we'll keep doing our math. So this was the critical step right here, okay? So we're gonna now add to what's in 1, instead of storing in 0, because that's a wasted step, because we've already got this number stored in 1, see? So now we're gonna add those together, and then we'll keep on moving. We'll do the final addition, and away we go. And last but not least, do the math with 0. And we should have completed it. Let's see what they say. There we go. Alright. Oh, we've completed the first, what did we not get on number 2 here? Let's go back to number 2, because we haven't got 2 green lights. Let's see what we can do with number 2. Inbox, outbox, jump. Using only 3 commands. Yeah? Let's see what they say. What are we not doing properly? I don't know how we could possibly speed this up, but... yeah. 30. Okay. So, they do say that you may not be able to do both optimizations at the same time. Now, there are 10 letters. I doubt we can handle multiple letters. Let's find out. Nope, we cannot. There are 10 letters. If we do 2 per iteration, it should still be... let's find out. That's 2, 4, 6, 8, 10. That should be... yeah. How many operations was that? Yeah, we failed that one. And this one... 25 steps. Okay, so... it's kind of interesting that they let you do that. You don't necessarily solve both at the same time. I don't think there's any way that this could be done in three commands and also 25 steps. But we got green lights on everything on the yellow path here now, so just got an achievement there. Looks like we've got quite a way to go, so I'm going to call it a day there and say thank you very much for watching. If you enjoyed this, please consider liking and subscribing, and we'll see you in the next video.